Today, we're going to be taking a look at the data and AI behind one of the more fascinating aspects of gaming, bringing characters to life through speech and facial animation. So we're delighted to be joined by Anita Klementiev, who is a senior speech data engineer at Speech Graphics. Anita has a background in informatics and linguistics and manages Speech Graphics multilingual audio data, working on projects that are at the intersection of data, AI, and gaming. Today, she's going to give us a glimpse into the datasets that power the audio-driven facial animation and some of the challenges that are involved in working with multilingual, emotional, and non-verbal speech data. So the session today, the way it'll run, Anita will speak for about 20 to 25 minutes, and then we'll have a Q&A at the end. So if you have got any questions, please do pop them into the Q&A at the bottom of your screen, and we'll get to those at the end. You don't have to wait till the end to ask your questions, just pop them in, and then we'll answer them all after the presentation. So yeah, that's everything from me. I'll hand over to you now, Anita.
Great, thank you. Thanks for having me. Yeah, let's just get into it. I'll share my screen now. Great. Okay. Yes, so as you just heard, my name is Anita. I work for Speech Graphics. We are a facial animation company based here in Edinburgh, which is where I live as well. And yeah, as Stephen said, we specialize in facial animation technology, and a lot of the applications of our technology are in the games industry. So just a bit of an overview of what I'm going to talk about today. I'm going to talk about our technology and also a background about how it works. Just kind of the underlying components of it. I'll give you a quick introduction to our product line and what we offer to clients. And then we'll talk a bit more about my role and my personal experience as a data engineer in speech graphics. What does my day-to-day look like, and what kind of speech and audio data I work with, as well as the different challenges that come with that. And we'll also close off by kind of looking forwards at the work that we're doing and the things we're thinking about to make even more high quality and immersive animation going forward. So yeah, I hope you enjoy it. But to start off, I've just got a very new show reel to show you that kind of will give you a bit of an introduction to speech graphics.
Easy, son. Come on.
I will explain.
Sit down and strap in.
What the hell? There's someone else in here?
Don't you answer me back!
Oh, you really don't know anything.
Est-ce bien de la
So that's a bit of an introduction to speech graphics. We covered a lot in this video. It's just a bit of a show reel that we can show to prospective clients and have on at the background and conferences and things like that. But we'll get a lot more in depth into speech graphics and our core technology, which is audio-driven facial animation. But what is audio-driven facial animation technology? Well, first of all, I think in order to have this conversation, we should start by talking about speech production. How do we as humans, make speech and audio sounds for us to interpret as language? We're going to get in a little bit into linguistics here. So what you're seeing here is a picture of all the major anatomical players that are used to create speech. This kind of picture is called a mid-sagittal section, and it's basically representing a cross-section of the face and exposing the internal anatomy that we use for speech. So in order to create speech, we pass up air from our lungs and through our heads into the outside world. And the main anatomical part of this is the vocal tract. So everything you see here is part of the vocal tract. Maybe turn my laser on. So you pass in lungs up through your vocal folds, and sometimes you trigger your vocal folds by making them vibrate, like if you touch your hand to your neck, you will hear and actually feel your vocal folds vibrating. And then the air passes through these parts of your face. So it can pass through your oral cavity. So like that's the sound passing through your mouth. Or you can pass the sound through your nasal cavity. So like so the air is not actually passing through your mouth, but you're still making a sound by passing it through your nasal cavity. And there's all these other bits that we call articulators. So some of these are active articulators, things like your lips, your upper lip and your lower lip. These are things that you can actually move around to create different muscle poses and shapes. And there are things that we call passive articulators, which are things that you can't actually move, but we interact with them in order to create different sounds. So things like your teeth, your upper and lower teeth, various palates on the roof of your mouth. The tongue is a really important player. It is the most important kind of active articulator. So for example, to make like a T sound, t, you take your tongue and you put it behind your teeth to what we call the alveolar ridge, and that makes a T sound. So combining all of these active and passive articulators is how we can create so many different sounds with our vocal tract. So now that we know how to create sounds, you have to put them all together in order to create speech. So this is a video that I'll show you very quickly. It's actually an MRI of someone speaking in real time. So the first video you'll see is some American English speech, and then there is also going to be some singing in Farsi. So let's have a quick look at this.
There are times in life when words do not matter. There are times in life when words fall short.
Oh, sorry.
There are times in life when the lack of words become more powerful than any poem, Bible verse, or song. A loving hug is all you need. No words.
So as you can see, it takes a lot of coordination of these articulators and these different parts of your vocal tract to create the sound that we can interpret as language. So there's a lot going on. So that's what we would call speech production, using your vocal tract to create audio speech. But what our technology does is the reverse of this process. And we try to reconstruct the muscle movements from the speech audio. So using this kind of technology, we can recreate the visual aspect of speech and give the illusion that the character you're seeing is speaking the audio that you are hearing. So the input to our technology is just the audio, and the output is this 3D movement of the face that makes it look like that face is speaking the audio that you're hearing. And yeah, it's like an inversion mapping, basically. So I'll show you just a short video that kind of demonstrates this using speech graphics technology.
Bean, beat, bends, boy, budge, cease, chip, chops, coat, coil, coin, coo, cook, found.
So as you can see, there's actually a lot of muscles that you need to move in order to create these, what we maybe think of as simple words and simple sounds. But by creating this mapping of poses to sounds, we're able to create like a universal model of the muscular components involved in speech. And a cool thing about this is actually kind of biological and independent of language. You can use our technology in combination with like a transcript where you've also written out what the character is going to be saying, but this is actually optional. We can actually predict the poses of the face just from the audio alone and without any transcripts whatsoever. So this allows you to animate characters that are speaking languages that you don't have any kind of transcription for, or even fictional languages, which we have done in the past for various kind of fantasy games and things like that. So now I'll talk to you very briefly about our tools and our products. So the first one is SGX, and this is our flagship suite of tools. This is what is used to create really high quality lip sync and expressions. And the tools in the suite can be used for character setup, visualizing animation, batch processing, fine-tuning, and kind of tweaking the final output. So this is what a lot of our clients in the gaming industry are using for the animation of their games. The next one is SGCOM. So SGCOM is like SGX, but it has the added benefit of it's real time. So with SGX, you maybe have the full audio or like many, many hours of audio that you want to animate already. With SGCOM, you never know what's coming next because could be someone speaking into their microphone during a game, and we have to animate the characters' expressions in real time to match up what they're saying. So this is a really cool and special product that we have. The next one is FaceFX. FaceFX is actually a product that we acquired last year. And this also does audio-driven facial animation. And actually, FaceFX was a competitor of ours, but now we've added it to our product line. FaceFX gives users really high levels of control over the final animation output. And it has another benefit of being very, very efficient in terms of batch processing and memory. So one thing that we are currently working on is a crossover between FaceFX and SGX so that SGX tools can be even more improved using the efficiency of the FaceFX runtime. And the final thing I wanted to mention is our sister company, Rapport. So this is maybe straying away a bit from video games, but what Rapport is basically an end-to-end solution for avatars that people can interact with. So currently, we're kind of targeting the learning and development industry with this product. So we basically Rapport combines our facial animation technology with new and like very exciting technologies like chatbots and high fidelity generative voices, and we can create really expressive human to avatar interactions that respond in real time. So this is kind of there's lots of applications for this, but currently we're working on a lot of like role play scenarios where maybe things are, you can walk through a scenario that can be used for training, say if you're doing some soft skills training or like doctor-patient interactions that are expressive and responsive. So that's just a quick overview of our products. Yeah, and you probably saw a lot of our clients and the companies and studios that we work with listed in the show reel. This is the point where I actually have to admit that I'm not much of a gamer myself, but I am very interested in the impacts of our technology in the gaming industry because obviously we have all of these very high-level clients. So yeah, there's so many people that use our technology, and for many, many good reasons, because modern games can contain so much, you can imagine huge amounts of dialogue. And sometimes this dialogue is repeated across different languages. A game will be released in many different countries, so you have to, have X times the amount of dialogue for every different language that you want to release your game in. So, and also there's an increasing demand for immersive experiences, high degrees of realism, character-driven narratives. So good facial animation is a huge part of this. It really enhances the realism and the character expression and emotional depth of these character-driven narratives. As you probably know, if you've played a game with bad facial animation, it can really take players completely out of the experience. And it really doesn't take much to take you out of that experience because we as humans, we're so attuned to faces, and we're really sensitive to any mismatch between the face and the voice, such as bad lip sync. And our technology is all automatic. All you have to do is stick your audio into our tech and it creates the animation for you. This is a lot more efficient and affordable than doing the animation by hand. You wouldn't go through and animate all of these tiny muscle movements for hours and hours of dialogue. That would be very, very time consuming. And solutions like motion capture can also be very expressive and a good solution for this, but that's also super expensive compared to something like a speech graphics tool. Nice. So next up, I'm going to talk a bit about myself and my role as the senior speech data engineer here at Speech Graphics. Yeah, so my name's Anita again, and I have worked at Speech Graphics since 2012. And I work in the research team. The research team, we kind of work on developing new features for our products, and we conduct a lot of very interesting research, and we're made up of data engineers like myself, linguists. We have people who specialize in linguistics who know a lot about how different languages look on someone's face. We also have machine learning engineers, and we also work with the wider company and the wider team with like software developers and the animation team. It's not a very big company, so we interact with each other a lot. But in terms of my work, my main work is kind of like data estate management. As you can imagine, we need lots and lots of speech data to power and improve our technology. So I manage this really specialized database of audio, 6,000 hours of audio, and millions of data files, basically. And it's not just audio data files, because we also have transcripts. This is important to know, like what is the actual target words of the audio that is in the audio file. Sometimes we also have video data, and we collect and store a lot of metadata about our audio as well. We're interested in the speaker gender, definitely the language. We also sometimes have metadata about things like dialect, US English versus UK English, things like that. Yeah, just lots and lots of different metadata. Also very specific metadata to what we do, such as emotion data, which I'll talk about in a bit. Yes, 34 languages. That's what we currently span in terms of what we have in our audio data estate. And also our audio data comes from a lot of different sources. So certainly we have audio data that's kind of designed for research. A lot of people release speech data sets for research into speech technology that are more open source. Sometimes you can even buy audio data training data is really valuable these days. So there are definitely data sets that we've acquired that way. We also do some of our own data collection. Sometimes there's just no data that really matches the spec that we're looking for. So we go into a studio and we collect the data ourselves. Or sometimes we collect annotations for speech data that we already have. And also sometimes clients give us data very kindly because they know that in order for our tech to improve, we need more in-domain data that's like, if we want our technology to work well on video game audio, it's of benefit for us to have more video game audio. So sometimes we are very, very kindly gifted data by clients. So a big part of my job is normalizing all this, making sure it's cohesive, and making sure the researchers can access this data in whatever configuration that they need. And of course, it's not a huge team, so I have a lot of other responsibilities, and I wear a bunch of other hats. I do tools development to interact with this data estate and our database. I also conduct data collection or assist on data collection. Sometimes we run our own data annotation campaigns. Sometimes we've hired, for example, interns from the University of Edinburgh linguistics department to help us annotate some data and get some linguistics experience in the field. I also work with data that has nothing to do with speech or audio. Sometimes I have been working a bit on business intelligence and dashboards for various different parts of the company as well. Great, so that's a bit of an overview about me. And I wanted to quickly talk about some of the more interesting data that I get to work with and the challenges that come with it, and also the features that we are building with this data. So the first thing is emotion. You kind of saw this a little bit in the show reel already, but our tools can detect emotion in voice. So just from the audio, our tools can say, oh, should we use a positive expression on the face or a negative one, or maybe a neutral one? So I have some clips here of generated animation from, I believe, Mandarin audio.
能够轻松地制作出如此高品质的脸部动画，真是美梦成真啊！我曾经那样期盼，愿得一人心，白首不相离。我从未见过有如此厚颜无耻之人。
Right, so yeah, that's just raw animation generated by speech graphics tools. No one had to kind of go in and animate those expressions. Those were just, we made a prediction from the audio that this is sadness or anger or happiness and created that animation. But there are a lot of data challenges that come with this in terms of how do you get all of this emotional data to create these predictive models? So we have quite a bit of audio data that we've collected over many years. And there's actually something that you maybe don't really think about unless you're working with this kind of data. For example, there's different kinds of emotional audio that you could have. You could have acting, like in a video game, like something super over the top acted. Obviously, we have an application for that sort of data. But also, say in maybe an SGCOM application, you're trying to create expressions for more spontaneous, real life emotions. So we have this different kind of emotion audio in our database. And also different languages. Emotion happens in all sorts of, in basically all languages, right? But we're better at recognizing emotions in our own language, but we are trying to create a system that detects emotion across all languages. So we need emotion data across many languages. Yeah, this is something I touched on before, different data sources. We definitely use lots of game data for this, but also there's a lot of research data out there as well in terms of more spontaneous emotion data that we can use to solve these problems. Different label sets is a huge one because every time you get a new data set, they've labeled it completely different. Sometimes there's only a few labels for different emotions, for example, 3, positive, negative, and neutral. Or sometimes the data set is annotated with like 20 different labels, like boredom, surprise, disgust, all sorts of different words that we can use to describe the emotions in the audio. So part of my job is normalizing those labels so that the data can work together as one data set. And then annotator agreement. This is how do you even know what happy audio sounds like or angry audio sounds like? In the case where it's acted, obviously the actor had some direction, but if it's spontaneous, then we're just kind of relying on our own perception. And one person's perception is not enough. We kind of need to be sure that more or less universally that people agree that, for example, the audio clip that we're hearing is happiness. So a lot of the time, the data comes with multiple annotations. So say if you had an audio clip and two people said it was happy and one person said it was neutral, then we think, okay, probably it's a happy audio clip. But if it's if one person said it was happy, one person said it was surprised, and one person said it was neutral, then maybe it's a bit vague and we can't really use any of those labels as a source of truth for the emotion of that audio. So that's, a bit about our emotion recognition model. And also we do non-speech sound detection. This is another great feature that our product suite can offer. So when I'm talking about non-speech, I'm talking about sounds that we can make with our vocal tracts that, aren't speech. So we can do a lot of other things. We can do crying, breathing sounds, grunting and effort sounds, screaming. A lot of these things are, particularly in games, non-speech audio occurs really often, and it has a high influence on the gaming experience. So let me just play you some samples. So the first one is breath. This is a new feature of ours where it can detect kind of the breath cycle. And because if you're hearing breathing in an audio, but the character is just speaking, but then when they stop you still hear breathing, but the chest isn't moving and the face isn't moving, that would kind of be off-putting. So it's really important to have these additional non-speech animations. So here's breath. Here's effort.
I'm losing my grip. Can you help?
And laughter. That one's a bit over the top. But yeah, obviously this comes with a lot of its own data challenges as well. There's very few data resources for this kind of audio data. And even if you did find data that has these different non-speech sounds in it, a lot of times it wouldn't be annotated to the quality that we would need it to, because with a grunt, for example, we don't just want to know that there's a grunt occurring in that audio. We want to know exactly where it starts and where it ends, because that's really important for the animation. So yeah, in this case, we have done some data collection ourselves. For example, recently there was a big lack of breath data for us to use for our breath model. So we visited a recording studio and collected a lot of breath data from our own employees. And we carefully labeled this data, for example, whether it's an inhale or an exhale, whether it's a nasal inhale or a nasal exhale, or an oral inhale or an oral exhale. So we're doing really, really fine annotations on this data because it's so important for the final output of the animation. Other challenges, well, the data annotation is really quite time-consuming, and it's not something that's available to us. It's something we have to collect a lot of the time. And label definitions, same with emotion, like we kind of have to internally agree what our label set is and what is a grunt, what is a scream, and and we have to kind of stick to those guidelines so that we can create an accurate model. And overlapping modes, sometimes you can be screaming and crying at the same time, or in that effort example, you can kind of have an efforts expression, a grimace, while speaking at the same time. So we have to have a system that can account for those things. And the data set that we have now, it's not huge. It's definitely not what you would call big data, but it's of extremely high quality. And this data is super valuable to us because it's not something you can find online, as I said. And we curated it and designed it for over many years for our own use case. So yeah, that's really interesting stuff for me and my team to work on. And I just kind of wanted to touch on things that we're looking forwards and working on or thinking about for the future to make audio-driven animation even better. So, for example, body motion. Your body can be in sync with your speech as well. It's not just your face and your head motions. You can do, hand gestures that are in sync with how you're talking. This happens a lot. So we're working on kind of beat detection and making body motions that are in time with your speech. Or look at what we call a feature where you can kind of direct the character to look at an object that maybe the character is talking about. So these are kind of different aspects of body motion that we're thinking about currently. Generative voices, I'm sure that all of you have seen and interacted with generative voices recently because they're definitely on the rise. They get better and better basically every time that I look at them. And they're used in so many different applications like customer service, content creation, and even games are now being released with these text-to-speech voices rather than human actors, because it is, of course, a very cost-effective way to have a lot of dialogue. So what we are really thinking about is how do we make sure that our technology works really well with these text-to-speech technologies so it's just as effective as it is on a human voice. Roleplay avatars. This is hugely relevant to our sister company, Rapport. Yeah, as I said, that we can create avatars and interactions that you can use for training, and this is a really interesting and exciting field for us. So, for example, if you're creating some sort of training for managers at your company, and you want them to practice a tough scenario like a promotion denial, they have to deny their employee a promotion. You want a kind of realistic feeling interaction that is maybe driven by AI, but it's also driving the expressions and how the voice sounds so that that interaction feels real, and you can kind of get a hang of practicing these more soft skills and, yeah, difficult conversations. This is, I think, a really great application of our technology. And yeah, leveraging AI in general, there's so many things that we can do. And some of the data challenges that I mentioned earlier, I think could be, we could definitely solve a lot of them by leveraging AI, that we couldn't leverage it in this way 2 or 3 years ago. So like things like data scarcity, like when I mentioned that there's just no data available for example, if you're not going to get 10 hours of grunting and effort sounds, but now you can actually prompt a voice to create those sounds for you. Or, for example, annotation. It's very, very costly to do annotation by hand. So maybe we can leverage AI to kind of kickstart that audio data annotation for us, and then we can have a lot more high quality data to work with. And also multilingual speech, you can generate speech in so many different languages now. So we don't really have to worry about, oh, do we need to get a Japanese speaker to act this out for us? We can actually create expressive audio data in any language that we can think of, basically. But yeah, Thanks, everyone. That's all I have for you today. That's actually a bit longer than I said I would talk for, but I hope you enjoyed that.
Thanks very much, Anita. That was really interesting to see everything that goes into creating the animations and the speech animations. My first question for you was going to be, what is your favorite game, either that you play or that you worked on? But you kind of answered that earlier that you're not really much of a gamer.
No, I haven't played any of the games myself, but it's definitely interesting to see our animation team working on some things and the challenges that they come across. For example, like with SpongeBob, he has such a weird shaped mouth, like the challenges that they talk about working with these interesting kind of non-human characters, I think is really interesting.
Yeah, I wouldn't say I'm a gamer as such. Probably the last game I played was probably the two or three GTA Grand Theft Autos ago.
Mm.
So I'm not the most up to date on computer gaming, but it's cool to see yeah, kind of the final product and kind of how it ends up. So yeah, well, we've got quite a lot of questions coming in throughout the session, so I'll maybe crack on with those while we've got the time. So
Sure.
we've got one here from Yana. Yana's asked, or said, it's a very interesting topic and lots of challenges. It's incredible how much there is going on when you speak and the amount of research that you've had to do. As games user researcher, Yana's curious about the evaluative research. How do you measure whether the emotional expressions generated by your technology accurately convey the intended feelings to players and truly resonate with them?
Mm. That's a good question. I don't think I'm fully qualified to answer that because I don't work on the animation side. But uh, basically, I think this is actually something that the client can control. So um, our system will predict kind of whether the speech is negative, positive, or neutral, but the expressions are highly controllable. So you can kind of map the negative to any sort of negative or any set of negative expressions that you would like your character to express. Now, I'm not really sure. I think sometimes we do the expression setup in-house, and sometimes it's something that is done on the client side. I'm actually not fully sure of that, but it's yeah, it's something that you can change the expressions depending on how you want it to look.
Maybe this would potentially you've kind of answered this already. We've got another question and is asking, does the AI do all of the work when it comes to the lip syncing and the expressions, or are there any opportunities where somebody could manually intervene and kind of change something where they think it maybe isn't quite right?
Yes, there's definitely opportunities for manual intervention. So when you first process some audio, it will, yeah, create all of the motion for you. But if something went really wrong, so for example, like if you can see sort of some of the output of our systems. For example, which part of the audio is which word. And if you see that that isn't lining up, you can move those word boundaries to make sure that everything is time aligned correctly. And same goes for the expressions. So you can see which expressions are outputted by the system. And if something is not looking right, you can actually change that. Yeah.
Brilliant, thank you. So we've got a couple of questions here from Tom. The first one is, I was wondering this as well. Do you have speech and language specialists in the team, like working with you full time?
Yes, absolutely. So I've worked with many people who come from a pure linguistics background, and they do really, really interesting work, particularly for improving our language-specific modules. So recently, we've really improved our Japanese module, and our data linguist, Samuel, he did a lot of research kind of looking at really tiny, tiny things such as nasal vowels. And sometimes we just have to do our own in-house research. So he has to go and watch native Japanese speakers on YouTube, pause the frames to see exactly what the mouth is looking like, because sometimes we get feedback from clients in different languages and they're saying, oh, these vowels or these consonants aren't quite looking right. So we really have to kind of be so detail oriented to make things look perfect. So that's where our linguists really shine.
Yeah, I guess they're noticing things that if you're not a specialist, you would never pick up on.
Mhm.
Um, and Liam's asked, and you mentioned this during the presentation, that there are some occasions where the audio data or the audio files that you need might not exist, or you need to go out and create your own recordings of audio. Could you give us some examples of, you mentioned kind of the breathing and the grunting side of things when you've had to go to recording studios. Are there any other examples where you've had to go and create audio from scratch? And is it just the audio that you collect, or do you have, so Gronya's asked, do you ever collect footage of people so you can, with sensors, to see kind of how they're moving as they say certain words?
Yes, so we've never done any collection with sensors, but we definitely have done collection with videos. So for the breathing, we collected it, not just the audio, but also the video, so we could, in case we needed to, we could see, maybe have more of a visual indication of whether it was like breathing in or breathing out, that sort of thing. And we do have various bits of video on file for that sort of thing. Other kinds of audio we collect is sometimes we just want really, really good acted audio. So we go to something like voices.com, which is somewhere you can go to get professional voice acting done. So we'll hire someone to kind of create a line that we can show to people, because sometimes obviously video game studios are very secretive about what they're working on and their data. So we just need something that kind of mimics that, but can be shared widely and that we own. So we'll often use voice actors to create demo lines to demonstrate our technology when we're talking to prospective clients.
Brilliant, thanks. You mentioned there about the gaming industry being quite secretive. There's a question from Ellie who said that gamers can be quite vocal in their kind of disapproval of the use of AI in creative aspects of game design. Is this something that you kind of have to be aware of with your work, or is it something the companies kind of keeps in mind?
Yes, for sure. I think kind of the phrase AI, I've even seen it kind of have fluctuations over the years. When I first joined speech graphics, we didn't have the word AI anywhere on our website. It's not, as I mentioned, a lot of our, I mean, 6,000 hours of audio is a lot of data, but compared to something like Google or, Meta, these are tiny, tiny data models. It's more about high quality data and the models that you can create with that. So yeah, now AI has kind of become more accepted and actually kind of a buzzword. So we use it a lot on our website now. But even though the technology is largely the same, so it's really interesting to see how this perspective has shifted over the years.
Right, thank you. You mentioned a couple of times the sister company Rapport. And somebody's asking, an anonymous question is asked, in the learning and development space, do you have a sense of where this technology works well and where it doesn't? For example, you mentioned role playing with maybe a senior manager who's practicing how not to, when they're not going to give a promotion.
Yes. Yeah, I think the applications it's really kind of, well, it is really new, so we don't actually have that much experience of this technology out in the wild. We have some clients that we're working with to create courses like this and training like this, but it's still kind of, we're figuring out what works the best. But definitely what we think this technology is useful for, it's not something you would just use to like quiz someone, like how well do you know the course materials. It's more about these kind of where you would need something more reactive and the conversation to follow a certain path, and maybe there's a couple of hurdles in the conversation. I don't know, maybe the person you're not giving a promotion to is kind of dismissive, or they have a certain idea in their heads and you need to set some realistic parameters, and these kind of more dynamic conversations. I think this is really where this technology shines.
Brilliant, thanks very much. So we've just got a couple of questions left. If anybody does have any other questions, feel free to pop them in the Q&A before we finish up, but we'll just move on with these two just now. So we've got one from Tom who's asking, are the movements from the articulators the same across languages? So, for example, are they transferable from one language to another, even though the words and the combination of sounds are different?
Yes, exactly. So you might have seen the International Phonetic Alphabet. So, when you see the pronunciation of something like on Wikipedia or in a dictionary, this is in concepts a universal alphabet of the actual physical phonetic sounds that are coming out of your mouth. So, and all of these, not all of these, but a lot of these sounds do overlap. So a lot of languages have the same vowels, or a lot of languages have the same consonants. But yeah, sometimes like this is a really old system as well. So sometimes our linguists find that, oh, the literature says that these sounds in these two languages should be the same, but when we show it to native speakers, they're saying, no, it doesn't really look right. So we actually kind of have to make our own call about whether two sounds are the same or they're different.
Yeah, the nuances there that you have to try and figure out. And then the last question, unless any more come in, we've got one from Anna who's asking a similar question actually. Are there many differences between how men and women create sounds, and does that impact the way that the animations are created?
No, so we don't have any distinction between how men and women create sounds. We use our gender metadata more for like a balance of our training data. We don't want it to be skewed too much one way or another, but um, as far as I know, there's not many differences that would impact our technology. Yeah, and sometimes we do have to test character like a male looking character with a female voice, and obviously it looks weird, but the lip sync should look fine.
Cool. Well, thanks very much. And we've just got one comment in from Elaine who said the NHS Scotland are testing as a way to create rehearsal space for difficult conversations. So exactly what you were saying there.
Cool.
Okay, cool. Well, there are no more questions coming in. So unless there are any last minute ones, we'll wrap up there. So thanks very much, Anita. It was really interesting. So thanks for joining us to kind of talk to us about your work and kind of the data sets that you're working with. For anyone in the community who's interested in what's coming up next, on Thursday this week, we've got another session with the team from Scottish Widows, who are talking about how they use gaming to open up the conversation around pensions and get people thinking about pensions through gaming. And then that'll be us wrapping up the gaming and creative industries theme for the month. Next month, we're moving into financial sector, and we've got a load of events up on the community at the moment taking place throughout September. So if you are interested in either kind of gaming and pensions, that's this Thursday, or financial sector throughout September. So have a look on the community and register for any of the events you're interested in. But otherwise, all that's left to say is thanks very much, Anita, and thanks for everybody for joining, and see you next time.
Thank you. Bye.
Bye bye. Thank you.